Today we're just going to practice using more law of sines, law of cosines, deciding what's best to use, and solving for the missing information. I'm going to skip the first problem. You guys will do and I will do the second one with you. You guys will do that first one later. We got to find x for that second one. And the way we do that, I know you see two sides, two angles, and you're thinking law of sines, but I need to have the angle across from 24 before I start. The angle across from 24, just take 180 and subtract your other two angles, and it will give you 92 degrees. Now that I have that, I can find my x using law of sines. So it's going to be 24 over sine 92 is equal to x over sine 32. Cross multiply. Divide by sine 92. And you end up getting x is equal to 12.7. Nearest tenth, so I know I'm good. And that's all I'll have to do for that one. So you guys will be stuck with the first one. Solve each triangle, which means find your missing parts. Whether it's the angles or the sides, you're going to find the missing parts. And there should be 3 pieces that are missing. Okay, so let's do the second one together. It's a little more difficult. I'll leave the first one for you guys. So in triangle ABC, we are given the following information. A is 15, B is 25, and C is 12. All sides. We've got to find all our angles. Alright, we've done one like this before. We got to use our law of cosines to start, and it doesn't matter which side we find first. Just to follow my notes, I did find angle C first. If I'm finding angle C first using law of cosines, it will start out as a 12 squared equals. And then it's your other two sides squared. Minus 2 times those two sides cosine of C. 12 squared is 144. 15 squared plus 25 squared is 850. 2 times 15 times 25 is 750. Cosine C. Subtract the 850. You'll get negative 706 is equal to negative 750. Cos C. Divide by negative 750. And do your inverse cos. C is equal to, and rounding to a whole number here, 20 degrees. Now, I chose to find, it looks like the angle A next. We could use law of cosines again. I'm going to choose to use the law of sines. So it's going, using law of sines, it's going to be 12 over sine 20 is equal to 15 over sine A. Cross multiply. Divide by 12. And do your inverse sine. You end up getting A is equal to 25 degrees. Now to find your third angle, which is angle B, just take 180 degrees and subtract off the two angles that you already found to give you an angle of 135 degrees. So you found your 3 missing pieces, which in this case happen to be 3 angles. And then we'll do this one together as well. Vertical telephone poles 15 feet high, braced from 2 wires from the 2 points on the ground that are 5 feet apart on the same side of the pole. So there's my pole. It's braced by 2 wires. It says those 2 wires are 5 feet apart on the ground. The shorter wire makes an angle of 65 degrees with the ground. Find the length of each wire to the nearest tenth. Since it's vertical, that's a 90-degree angle. We are looking for that side and that side. So I'm looking. And maybe you see in that smaller triangle already, you could use your law of sines to find x. 15 over sine 65, x over sine 90. Let's do that. Cross multiply. Divide by sine 65. And you end up getting x is equal to, nearest tenth it says 16.6. Now, alright, we have to find that third side. That angle, that y right there. If I'm looking, let's see what I am given here. I could find this angle right here, and then use my law of cosines. That angle right there is going to be 180 minus 65, because that makes a straight line, so it adds up to 180 degrees, so 115. I could use law of cosines now to find y. Using law of cosines, it'll be y squared equals my other two sides squared minus 2 times those two sides cosine of 115. Missing pieces by itself, so you type the whole right hand side in your calculator. You remember you do have to take a square root of that. You will round to the nearest tenth, and you will get 19.3. And that's it, there. At this point, you can do the problems that I skipped, and we'll practice more tomorrow in class.